Okay. So a rope which is wound around a drum of diameter 21 centimeters is attached to a bucket that is resting at the bottom of a well. Okay. Find the number of complete turns of the handle required to bring up the bucket such that the bottom of the bucket is suspended just above the mouth of the well. Okay. So that means that Arad, if actually your answer is by this 14.99. All right. But you are answering this 14. If you just actually turn this handle of this, what is it, that drum, right, 14 times, your bucket will be somewhere here. That means that still it's not outside this well. And actually, why is this problem given here? We are trying to take this bucket out of the well, right? So that means that still it is in the well. So if it is like 15, for example, right, it's already outside this well. So they can take this bucket out of the well. Okay. So your question actually is 14. What is this 14? This bucket will not be outside the well. Do you understand the problem?
Yes, now I understood. Because first I thought that just we need to run, but the bucket shouldn't pass the thing.
Okay. In the future, also, we will see more this kind of questions. It's not only round off, it's about solving the problem. Okay. How many turns actually we need to make so that the bucket will come out of the mouth? This is the mouth of the well, right? So because our goal here is to take this bucket out. If it is 14 still, it will be here. Your hand may not be enough. Actually, it's 14.99. You are rounding 14. Actually, here we have 99 centimeters. It's quite long. It's still inside the well. Okay.
Okay,
And about next question, I think it's about a little bit
I didn't do this one.
similarity, and we'll do this here together. Okay, we are talking about the trapezium ABCD is such that AD is parallel to BC. The diagonals AC and BD of the trapezium intersects at E. If the length of BD and BEE are in the ratio 5:4 and the area of AB is 20, find the area of the trapezium. Okay, and actually, let me just draw, but it's not to scale. We are talking about this kind of trapezium. Okay, that's our trapezium. All right. So AD is parallel to BC. So that means that if I start from here, that is, let's say A, B, C, D, right? So AD is parallel to BC. And if the length of BD to BE, right? BD to BE are in the ratio. What is E? Okay, all right. So here, this is the diagonals, right? Okay, all right. This point is E. It states that, okay, the diagonals AC and BD of the trapezium intersects at E if the length of BD and BE are in the ratio. That means that BD to BE is in the ratio 5:4. And the area of triangle ABE, triangle ABE is equal to 20. Let me just not write the units. Okay, we understand, talk about the area. Okay, equals 20. I got here. It's okay. So what is ABE? ABE is, we're talking about this triangle, right? Okay, we're talking about this triangle. Anyway, so what is the question here? Find the area of the trapezium. All right, we are looking for the area of the trapezium ABCD. Okay, that's the question. Before I continue here, I would like to just remind you with one thing, I mean, one formula. Maybe I can just throw here, okay, then I'll continue there. So now if you are given any triangle, okay, any triangle, let me just divide this triangle into two parts. Let me just divide from here, all right? And let's say the area of this part of the small triangle is A. The area of this part is, let's say it is B. And this length, let's say it is A. And how about this remaining part? Let's say it is B, right? So actually, if I just drop the height, right? And what is the area of A? That is 1/2 times base times height. And how about the area of B, the region B? That's again 1/2 times, what is the base? Base is B, and height is the same, right? From this point to this line, the distance is, the shortest distance is the same. So that is H. Now, how about if I take the ratios? A to B will be equal to 1/2 times A times H over 1/2 times B times H. Now H cancel out with each other. 1/2, 1/2, they cancel each other. That means that here we have A over B. So the ratio of A to B is just the ratio of this their corresponding bases, right? That is A to B. Okay, Eldar, did you understand this?
Yes.
Arat, is it clear?
Completely.
Okay, now I'm going to use this idea, okay, this formula to find the question. So what is given here? BD to BE is 5/4, right? What is BD? BD is this one, right? And BE is this one. So if I just denote this BDE by, let's say it is 4x. What is the length of BE? It will be x, right? As you see here, what is BD here? BD equals, actually here, actually BD is 5x. And how about BE? It is 4x, right? It is, if BD is 5x, then BE must be x, because DE is BD is what? Wait. BD is 5x, BE is 4x. Okay, I'll just make a small change. Good. When I just write like this, that's a little bit, let me just write like this. Doesn't matter, but here it doesn't look good. A, B, C, D. Now from here, BD 5, BE 4. A, B,
From
C.
D to E should be 4. No, I mean from B to E should be 4.
I think I should just write like this. Actually, it doesn't matter, but here, because of my drawing, actually, it doesn't look, because B is quite long, right? I think it's fine. Now, from this picture, let's say our trapezium is A, B, C, D. So AD is parallel to BC. And the ratio of BD, right? The ratio of BD to BE, that is BD to BE is 5/4. What does it mean? That means that if BE is 5x, then ED must be x, because BD here is equal to 5x centimeters. And DE is x centimeters, right? So at the time BE, what is BE? Okay, BE.
Teacher, but
Wait.
BE should be 4x
Okay,
from B to E,
BD and
not
BE. All right.
5x.
Yeah, good. Because BD, right, the whole length is 5x. So this should be 4x. Okay, now I think it's clear what is given here. We know the area of ABE, right? Now from here, my first step is to see here the area of ABE, the area of ABE to the area of, let's say, triangle ADE, right? Using this formula, as you see here, Actually, I'm just dividing the triangle ABD into two parts at point E. So since the ratios actually it is 4x to x, so what is the area of ABE? It is 20 centimeters. And how about the area of ADE? I don't know. Let's say still it is area of triangle ADE. And from the formula we have just written, that should be equal to the ratio of BE to ED, right? What is BE? BE is 4x. And how about ED? It's equal to x, right? Now from here, if you just solve it for the area of ADE, that should be equal to, what is it? 20 over 5. It should be equal to 5. Okay?
Okay.
Good. So now I know this area. Let me just write 4x here. Actually, I know there's one 4x here. This area is in blue. This ABE, that's equal to 20 centimeters squared. AED, we have just found it is 5 centimeters squared. Okay. So now another thing is, what do you think about the triangle AED and CEB? Are they similar? The second part is, what about triangle AED? Is it similar to triangle CEB? Right? Because this one is a common angle. I mean, this vertical angles. And since this side is parallel to this side, and this angle should be equal to this angle. At the same time, this angle should be equal to this angle. That means that triangle AED is similar to triangle CEB, right? So what does it mean? If these two triangles are similar, that means that their corresponding sides are proportional. That means that from here, CE, right? So from here, let me just have from here, AE to AE is opposite this angle. Here, opposite this angle, we have CE, that is CE. And here, it is DE, and DE corresponds, which one is it? BE, right? So do we know these ratios? What is AE? Do we know AE? We know, right? Do we know? We don't know. So it is
No.
AE. And how about CE? Do we know CE? We don't know. It is CE. And how about DE? We know DE. That is X. And how about BE? We know that. That's 4X. That's equal to 1 to 4. So what we have found here is the ratio of AE, right? AE to CE is 1 to 4. That means that if AE is, let's say it is M, so this EC must be 4M, right? So now from here, if this base AE is M, this area is 5. What do you think about this area then? It should be 4 times 5, right? Because the ratios are equal. So this should be 20. Okay,
Why that one?
did you understand?
Did you write DEC? Why not BEC?
No. Look at this triangle here. DEC, I'm talking about DEC and ADE. Right? What is the area of, let me just write like this, area of, not line.
I answered.
Okay, ADE. Okay, good. So area of ADE over area of CDE. That's equal to M over 4M. We know the area of ADE, that's 5, so that's why it should be 20. Now, in similar way, Arad, if you just like from here, also from C to B to D, look at triangle CBD. And with this line CE, I'm dividing them into 2. So this length, we know this is X, and this one is 4X. So if this area is 20, this should be 80, right? You understand this X to 4X equals 20 to this area. If you solve this, so this area is 80. So from here, what is the area of the trapezium? The sum of the areas of these 4 triangles, that is 20 plus 5 plus 20 plus 80, which is equal to 125 cm squared. If you just draw a bit bigger with your ruler, you can understand much better. Just I'm using 2 facts here. Number 1 is, if you are given any triangle, if we divide its side by a kind of line segment, and the area and the ratios of those areas is equal to the ratio of their corresponding sides. And number 2, the similarity. Okay, because we know that if 2 triangles are similar, that means that their corresponding sides must be proportional. Okay.
Okay.
Good. Also, Eldar, any question?
No. Oh.
Good. All right. Guys, this question, very famous question.
I
Right?
just know the strategy, but I don't know the proof.
Yeah, the proof is, what do you mean? We don't know the proof. Here, the difference between these 2 products, right? It is 1. It is 1. It's 1. In general, it is something like this: 1 over m times m plus 1, right? And if it is so, I can just write it as 1 over m minus 1 over m plus 1. Actually, in math, we call this decomposition. Decomposition. Decomposition means decomposing this fraction into partial fractions. We call them partial fractions. If you have ever played, like, maybe actually if you have any little brother or sister, or maybe niece or nephew, anyway, whoever is like 1 or 2 years old, usually they play with building blocks, right? You know, the small blocks, and using them, they can make a kind of tower or house. So if you, by assembling them, we make a house, right? By dismantling these blocks, actually, I can just decompose them into smaller pieces. It's something similar. I can combine these 2 fractions, I get 1 fraction. If you decompose these fractions into partial fractions, I get these 2 fractions. If you simplify, you'll get the same thing. So that's why this one, I can write it as 1 over 1 minus 1 over 2, plus the second one, 1 over 2 minus 1 over 3. The third one, 1 over 3 minus 1 over 4, plus dot, dot, dot. How about this one? The same thing here. 1 over 2019 minus 1 over 2020. Now, if you look at these numbers, right, the same, but the signs are opposite. So actually, all of these numbers, they cancel each other. 0, 0, 0, and here also, here we have 1 over 2019, 19. What is that here? Only the first term, right, and the last term. That's equal to 1 minus 1 over 2020. So now if you just bring into a common denominator and simplify this, we get 2019 over 2020. Okay?
Okay.
Very good. Also, Eldar, any question? Eldar, when will you introduce yourself to us? Oh, disappeared. Okay. All right, let's continue. How about this question? Also, do you have any idea? Did you try to do this question, question 14?
Yes, but I didn't really understand.
Okay, it's also a very interesting question. Eldar is back. Arad, what's your answer? What was your
I got
answer?
64.
64?
Yes.
Okay, I'm very close, but a little bit.
My
a kind
idea
of-
was this.
Say again?
My idea is this: E, C, and B should be the separate color in all of them, and A, D should be the same color, and then playing with them.
But here it says that Arada, I think one keyword here, I mean, important point. In how many ways can the figure shown below be colored using 4 different colors? Okay, so that the adjacent regions. Okay, what does adjacent regions mean?
Connecting ones.
Adjacent regions means sharing the common side.
Which AD don't. The only the one which don't AD.
Okay, for example, here, let's say the region B and E, are they adjacent to each other?
B and D? No.
E, B and E,
Ah,
B and E.
no.
So that means that they can have the same color, right? Because they are not adjacent. If they are not adjacent, they may have the same color, or they may be colored using the same color. You understand? So that is a tricky point here, Arad. I think you actually made or confused at this here. Okay, guys, let's continue. So here we have 4 different colors. What colors are they? Let's say color 1, maybe green. Let me just write here instead of in general case. Let's say we have 4 different colors. Let's say there's red, blue, yellow, and the green. Okay. So we have red, blue, yellow, and green. All right. Now I start painting starting from the left hand most side. So the first region is A, right? So how many possible answers I have here, and how many different ways I can color A? 4, right? Either I can color this red or blue or yellow or green, right? So that means that here I have 4 choices here. Okay, now since it says that so that the adjacent regions have different colors, that means that now A is adjacent to C because it is sharing this border, right? It's like border. As Azerbaijan is border to some countries, something like that. So actually border. That's why if you look at the map, actually, they color the map with this idea, with this logic. If you look at the map, we do not see any 2 countries that they are bordered to each other and they have the same color. We don't have any 2 countries in the world. If you just look at the world map, you just see that. But 2 countries may have the same color. Maybe one is South America and another country is in Africa, for example. One is in Asia, another one is in Europe, for example. It's no problem if they are not sharing a border, so we don't get confused, right? But if you just use the same color for 2 countries, they have the common border, or they are sharing their borders. That doesn't make sense. Okay, that's something like this. So here, if I have already used one color for A, for C, how many different colors I can use? Now I can use only 3, right? Because I cannot have this A and C, they cannot have the same color. Okay, now for A, I use already one color, also C, one color. Now B, it is adjacent to A, it is adjacent to C. So how many possibilities we have for B? We have 2 options, right? And how about for E? For E, okay, how about for D? Let's say for D, for B, we have already used one color, and C, we have already used one color. It is also, it is adjacent to region C and region B. So how many options we have for D?
3?
2.
Oh, 2, yeah.
Because here I have already used, if I use red here, let's say it is blue here, for D, I can use only yellow and green, right? Because it is adjacent to B and C. Now, also is question for you. How about for E? How many different colors I can use for E?
Can I?
Yes, Arad.
Only 2.
Only 2, right? Because already it's adjacent to this and to this region. So now it just takes permutation right here. Then what is, and how many different ways we can color them? It is 4 times 3 times 2 times 2 times 2, which is equal to 4 times 3, 12. 2 times 2 times 2, it is 8. That's equal to 96. In 96 different ways we can color these regions under this condition. What is the condition? Actually, adjacent regions should have different colors. Okay.
Okay.
All right. Good. So, guys, now also let's solve this question 15. Okay. And after that, we'll have break and continue our class. And since we solved until here, all right, can you read the problem?
A journalist need to travel another country. He can choose to drive for 15 hours and then travel the remaining journey for 20 hours. Otherwise, he can drive for 8 hours and then travel the missing journey for 34 hours. How many hours must he drive at least if he chosen to drive for the whole journey, and give that the spent is in the whole number.
Okay, given that if he chooses to drive for the whole journey, right? And given that the time spent is a whole number. Good. So actually, you're talking about traveling from, let me just write here, A, and here we have B. Okay, here we have A to B. So from A to B, we have two options. In the first case, this is our first case, and that's our second case, right? And second option. It says he can choose to drive for 15 hours and then travel the remaining journey by train for another 20 hours. So that means that, let's say the speed of the car, it is D kilometers per hour, and speed of the train, let's say it is okay, if I do like this, you may get confused. So let me just write here, X kilometers per hour, Y kilometers per hour. So in the first case, it says that 15 hours by car. So that, let's say the distance is equal to D. I mean, the distance between these two cities. In the first case, so distance is equal to, first he travels by car, how many hours? 15 hours. By train, 20 hours. So that means it is 15x plus 20y. And how about the second case? It says that otherwise he can drive for 8 hours. He can drive for 8 hours and then travel the remaining journey by train for another 34 hours. So 34 by train. Okay. So how many hours must he drive at least if he chooses to drive for the whole journey, and given that the time spent is a whole number? The question is the whole journey if he travels by car. Let's say the time is T and the speed of the car is X kilometers per hour, right? So the question here is we need to find time, and T is, or is it? T is a whole number. Whole number means just natural number here because T cannot be equal to 0. So that means it is a natural number. So just we have to solve this question. Now from here, you know that see here left hand sides are equal. So from here we have 15x plus 20y should be equal to 8x plus 34y. Take 8x to the left hand side, that is 7x, and 20y to the right hand side, that is 14y. Or x is equal to, what is it, 2y. That means that the car speed is twice the train's speed, right? So if I just substitute either in the first or second equation, what do we get here? Let's say if you just substitute here, doesn't matter which one we substitute. Okay, so that is the first step, and here the second step. So here D is equal to 8x plus 34y. So 34 times, what is y? It is x over 2, which is equal to 34 is divided by this 17. 17 plus 8 is 25 x. So actually we were looking for this t times xy that's equal to d. That means that if he travels only by car, it takes at least 25 hours to arrive at the city. I mean the other town. Okay. So dot, dot, dot. The answer is 25 hours by car. Also, Eldar, is it clear? Did you understand this question?
Yes.
Eldar, why is your camera always off? No answer. Okay. Guys, let's have break for like 4 minutes. Okay, now that's all about this test. And now we will talk about circle. Okay.
Can we
Okay.
discuss one of the questions also?
Sorry.
One of the question. In it was 9C triple I.
9C.
Yeah, triple I, triple I.
9C triple I.
And what is figure?
Which is it this question? Which figure will use
Yes.
up 210 beats?
Because I did it one by one, it take a lot of time. Is there a formula for
Yeah,
it?
of course, of course. Actually, I can ask here, how about not 210, how about 5050, for example? At the time, you cannot answer the question using that. You can answer, of course, but it takes maybe a few days. Anyway, so here in this question, study carefully the pattern below, showing the number of beats in each figure. What is it? It's a kind of problem related to number sequence, right? In this kind of questions, the idea is we need to find a formula for a general term. Okay, how do you find this? Okay, first, if you just study the pattern in the first figure, we have 1 bead. Second one, we have 3 beads, and the next one, 1, 2, we are adding 3, right? So that is, what is it? 6 beads, and 1, 3, 6. Here we have 10 beads, right? So each time, actually, the second one we add 2 more. Third one we add 3 more. Fourth one we add 3 more. If you notice here, actually here we have 1. What is 1? 1 is 1 times 2 over 2. And how about 3? Actually, these are just the sum of natural numbers, because here, what is it? It is 1. The second one, 1 plus 2. And here, 1 plus 2 plus 3. Next one, 1 plus 2 plus 3 plus 4, right? And if you know Arab, actually, we know that the sum of n natural numbers, 1 plus 2 plus 3 plus dot, 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 n numbers, what is the formula? It is n times n plus 1 over 2. And proof is very simple. Maybe later when we talk about this in a more general settings, at the time I may prove this. But proof is very simple. Okay, if you just rewrite this in the reverse order, I can just write it like n plus n minus 1 plus dot, dot, dot plus 2 plus 1. Now, if you add side by side, what is s plus s? It is 2s. 2s. And here, n plus 1, it is n plus 1. If you just add them, they're all n plus 1. 2 plus n minus 1, n plus 1. 3 plus n minus 2, n plus 1. And the last terms, n plus 1, right? How many n plus 1s do we have here? Starting from 1, 2, 3, n. So here we have n plus 1. Now, if you just divide both sides by 2, here we have n times n plus 1 over 2. That is this thing here. The first one is 1. The second one is 1 plus 2. Third one is 1 plus 2 plus 3. Next one is 1 plus 2 plus 3 plus 4. So if it is nth term, if you just continue here, let's say figure n. How many bits will we have here? So that Sn, the number of figures, will be n times n plus 1 over 2. Because in n figures, right, in nth row, we will have n dots or n bits. If you just add them from 1 plus 2 plus 3 plus blah, 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 n, then your sum will be just the sum of the first n natural numbers. So using this one now, we need to solve this question. Since it says that how many beats do you need for the seventh? No. Sorry. Which figure will use up 210 bits? N is a number of figure, right? So here, let's say it is n. So that is n times n plus 1 over 2. That is equal to 210. Just we need to solve this question. Now, how can I write this 210 in this form? Of course, actually, also we can solve quadratic equation. A simpler way is just guess and trial. We know that 210 is 420 is divided by 2. And how about 420? Can I write it as a product of two consecutive numbers? Yes. What are these? They are 20 times 21 over it is 2, right? As you see here, if n equals 20, this n plus 1 will be 21. So dot, dot, dot in figure, which one? In figure 20. So in figure 20, actually to form this figure 20, we have to use 210 beats. Okay, Arat?
Okay.
Now, if you know this idea, it doesn't matter actually this 210 beats or 10,000 beats or 1 million beats, just using this formula because we know the general term formula here. So we get the answer. Okay. Now let's have a break for like 4 or 5 minutes, okay? Let's say 5 minutes. After 5 minutes, we will continue. Good. So we have around 15 minutes at least. Let's start. God, that is the last part of chapter 4. As you know, chapter 4 is about coordinate geometry, and we talk about the length of line segment, the gradient of a straight line, the equation of a straight line, and midpoint of a line segment, and area of a rectilinear figure. Okay, in your next test, I may include some questions related to these things. And before I forget, also Arat Eldar, you will have another test, test 3, okay, next Saturday, and that's it, okay, from chapter 1, 2, 3, 4, 5. Okay, now let's talk about the circle. And as you know, circle also is one of the, let's say, the most beautiful, one of the most beautiful geometric figure, right? And it is used a lot, right? As you see here, if you just look at the bicycles, you will see circles. If you look at the wheels of cars, you see circles and circles, circles, a lot of circles. And it has a lot of very important special properties. That's why it's used a lot in engineering also. Anyway, you will actually see that it's very beautiful and nice and so useful geometric shape. So what is the geometric definition of this circle? So since we are talking about coordinate geometry, right? So actually the definition is we are given a plane. When you talk about geometry, always we use 3 different things. I mean, main ingredients. The first one is, what is it? Point. Second one is line. Third one is plane. So now this white part actually in the screen, let's say it's our plane, okay? On the plane, I just fix one point. Look, this is, you are my point, just stay here. I'm just fixing this point. Now, if you just consider all the points in this plane, which are equidistant from this point, that is the red part, right? Actually, here we have infinitely many points. That's why it looks like a, what is it? Just a line. Actually, here we have a collection of infinitely many points. So actually that description, actually those points give us a circle. So what is a circle then? It is a collection of all the points in the plane which are equidistant from a fixed point. So this fixed point also is important point. It deserves some special name. We call this the center of the circle, okay? And the distance between this fixed point to any point on this circle, we call the circumference. We call this a radius, right? And if you just join any 2 different points of the circumference with a line segment, we call this chord. Actually, you don't have to know here right now. So the longest chord or the line segment that passes through the origin, I mean the center, and joins two different points of the circumference of the circle, we call this diameter. Anyway, these things, that much is enough for this part. Okay, more circles, I mean more things about circles we will talk later. So only here our point is we're going to take everything in the context of coordinate geometry. Okay, so now our purpose is immediately we know that actually there's a kind of interplay, right? Relationship between geometry and algebra, right? For example, quadratic equation or quadratic function. Actually, if you just plot the points that satisfy this equation, right? And we get a parabola. So also like this, how do we write the equation of a circle? Okay, to get this, I'm just going to use the definition of a circle and distance formula. Assume that's actually first to draw or to write the equation of a circle, we need two pieces of information. Number one, we need to know it is center. Okay, where is the center of the circle? Okay, now you want to draw a circle, but what is the radius of the circle? If you don't have these two pieces of information, we cannot talk about the circle, right? We need to know it is center, and number two, we need to know it is radius. And after that, we can talk, you're talking about this circle. So assume that we are given the center of the circle, that is H and K, that's the center. And suppose that we are going to draw a radius the circle whose radius is R. Okay, so then what is the equation of the circle? All of these points. How can I describe all of these points using algebraic equation? To do this one, since we know that actually all distance, right, from this point to any point, they are equal, let me just pick one point to represent the whole circle. Let's say whose coordinates are X and Y. So from here, if you find the distance between X, Y, and O, let's say that the center is O, and this point is, let's say this P, what is POP? That OP is the radius of the circle, right? So the radius of the circle is just distance formula, square root of X minus H squared plus Y minus K squared. Now, if I just square both sides, we get the equation of a circle. What is it? That is X minus H squared plus Y minus K squared. On the right-hand side, we have R squared, right? So we know what is H. It is X coordinate of the center of the circle. We know what is K. That is Y coordinate of the center of the circle. And we know R, that is the radius of the circle. So actually, any equation in this form, it describes a circle. Now, what happens if I just expand, for example, the left-hand side and just simplify a little bit? So left-hand side, we have X squared minus 2 times H, or not H, okay, H X plus H squared. And the second one, here we have Y squared minus 2 times K times Y. Plus, here we have K squared. And take R squared to the left-hand side, here we have R squared is equal to 0. Okay. So let me just reorganize this and write in this form. X squared, and after the plus Y squared, and after that here we have minus 2HX minus 2KY plus H squared plus K squared minus R squared is equal to 0. So these are just the numbers. It's also just number, right? It's also just number. So if I just use some numbers for this, for example, AX squared plus Y squared, instead of minus 2H, let's just write here F X. Instead of minus 2K, let me just write G, because it's just a number, relabeling this Y. And here we have H squared plus K squared minus R squared. Let's say it is FGH. No, I should, how about ABC? Okay, I can just write ABC, doesn't matter. Let me just write a capital A, capital B, and here we have C, that is equal to 0. Okay, Even if you just for any equation of this form, also actually it is the equation of a circle. Okay. Anyway, that's all about circle. All right. Now let's solve maybe 2 questions and finish the class. The first example, find the equation of a circle with center C, whose coordinates are 2 and 3, and radius 5. So here, let's say we are talking about this circle, and that is the center of the circle, whose coordinates are 2 and 3. And let's say that's any point on the circumference, and radius is equal to 5. Then what is the equation? The equation of the circle is x minus 2 squared plus y minus 3 squared is equal to 5 squared. I can just leave the answer like this, or if they ask, sometimes in the question, they may ask you to expand and simplify this. At the time, here we have x squared, plus here we have y squared, minus here we have 2x, and here we have 4x, here we have minus 6y, here we have 4 plus 9, 13, 13 minus 25, that's equal to minus 12. This is just another form of the equation of this circle. Okay. And depending on the question, either you can leave your answer in this form or in this form. Actually, both equations represent the same circle, but in different forms. Another example, find the equation of a circle with diameter AB, where A and B have coordinates 4, -3, and 2, 1 respectively. Okay, so we are given a diameter. So that means that if you know the diameter, also we can draw a circle, right? So let's say that one is the center of the circle. So that is this line segment is equal to this line segment. Actually, we call them radius, radius, right? So as you know, to write the equation of a circle, we need 2 pieces of information. I need to know R, we need to know the coordinates of the center of the circle. Let's say its coordinates are H and K. And since these line segments are equal because they are radii, that means that O is midpoint of A and B. And we know how to find the midpoint, H and K, right? What is H? H is 4 plus 2 over 2. That is x1 plus x2 over 2, which is equal to 3. And how about K? -3 plus 1 over 2. -3 plus 1 over 2, which is equal to -1. So now we know the center of the circle, that is 3 and -1. Next thing is, we know the radius of this circle. And how do you find the radius? Radius is equal to either OA or OB. They are equal actually here. Let me just use OB. What is OB? Square root of, here we have 3, and coordinates of B, let me just write here, coordinates of B, they are 2, 1, right? And 3 minus 2 squared, 3 minus 2 squared, plus -1 minus 1 squared, which is equal to, here we have 1, here we have 2, it is 4 plus 1, it is square root of 5. So now what is the equation of the circle? Equation of the circle is, here we have x minus h. What is h? It is 3 squared, plus y minus k. K is -1, so here we have plus 1 squared. And here we have r squared, so that is 5, because r squared is 5. Or here we have x squared plus y squared. From the first one, here we have minus 6x plus 2y. Here we have 9 plus 1, it is 10. 10 minus 5 is equal to 5. So that's equal to 0. So either this equation or the previous one, they describe the same circle. Any question? Also, Arat, Eldar?
No.
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 You must be tired. Okay, guys. So next time we will solve a bit more questions about circle, and I will finish this chapter. And again, next Saturday you will have quiz, okay, from chapter 1, 2, 3, 4. And chapter 5 is very short chapter. It's about matrices. Chapter 6 is a bit long chapter. It's about application of math. And in this way, we will continue. Guys, what I suggest you also are at Eldar. If you want to enjoy something, first you should know about that thing a bit more. Now, for example, Arad, I know Arad a bit more because in our first classes, always he was keeping his camera on and we have some discussion face to face. So I have some idea about Arad. But also, Eldar, you always keep your camera off, okay? But I hope you are listening there and you are working. And as you see, your test results are not so good. So you need to keep practicing more questions. If you have question anytime, just you can ask me, okay? Also, Eldar, if you just let me know, we can meet one to one, maybe like 10 or 15 minutes. I will try to help you. Or if you have any questions, I'll try to answer. We may have discussion face to face. Okay, guys. Thank you very much. I wish you good luck. I already shared this chapter for questions. Keep doing these questions. Okay. I will meet you next Tuesday. Have a nice weekend. Bye bye. See you next Tuesday.
Bye.
Bye. Thank you.
Bye, Mr. Kasim.